Hi all, in this video I will be covering about this CPU scheduling. Okay, so in the last video itself I planned to cover CPU scheduling, but the last video got slightly longer, so that is why I plan to make another video regarding this CPU scheduling. Okay, so in a single line, if I tell you what is CPU scheduling, let's say there is a CPU. Okay, P1 is currently getting executed at CPU level, and in your system P2, P3, P4, P5 is there. They are in what? In ready state. They are waiting for the CPU. So CPU scheduling says after P1, among all these ready states, which process will be getting CPU. This is all about CPU scheduling. Now let's start today's video. So the main purpose of CPU scheduling is we want to maximize the what? We want to maximize the CPU utilization. So there will be some time, there might be some time, during that time your CPU may end up staying idle. So we want to minimize that time as much as possible. So that says we want to maximize the CPU utilization. Alright. So CPU scheduling is taking a process from ready state and putting this in running state. This is all about CPU scheduling is. So we have already seen, okay, this diagram. From ready state there is something called running state. Dispatcher comes and does dispatcher comes and does the heavy work of scheduling one process into this RAM. We have already discussed this thing. Now the question is, CPU scheduling is nothing but choosing. Okay, let's say there is a CPU. P1 is getting executed at CPU. Let's say P2, P3, P4 and P5 is waiting. So CPU scheduling is nothing but deciding which process among these four processes will be given to the CPU next. Let's say short-term scheduler has decided, okay, let's give P3 to the CPU next. Okay, this P3 to be given to the CPU next. What will happen? Now dispatcher will come and will do all the needful jobs that it has to done, so that successfully P3 is getting scheduled at CPU, something like that. Okay, fine. So the next thing is let's see when CPU scheduling takes place. Okay, let's say this is your run state. So run state as in there is a CPU and there is a, let's say, process 1 is getting executed at CPU. Alright. So whenever any process is taking this path or this path or this path, whenever your process is taking this path or this path, then only your CPU is free. Then only you can schedule one more process into the CPU. So ready to run. Okay. So whenever a process, what is scheduling? Scheduling is taking a process from ready state and putting this process into run state. All right. So assumption is this system is having only one CPU, one core. All right. So the question is when scheduling comes into play. Fine. So scheduling comes into play in two cases: when your CPU is free or you have some high priority process that has recently come. Okay, fine. So first question is when your CPU is free. So your CPU is free when it has no process to work on. Even though this is very rare cases. Okay. So when your CPU is free, then happily one scheduler can come and can schedule one different process. Alright. And there is one more case when your CPU becomes free. Let's say there is a CPU and there is a process currently getting executed on the CPU. Fine. So that means this process is on running state or run state. So when this process from run state goes to either terminate state or wait state or ready state. If you see this, okay, so either this terminate state or ready state or block state. Okay, in any of this wait, in any of this transition, your CPU becomes free. Then scheduler can come and can schedule one more process. All right. When a running process takes any of these transitions, then CPU becomes free. Immediately this scheduling comes. Okay, and one process is scheduled. Now let's see one more case. Let's assume some high priority process has come. Okay, so let's come here. Let's say this is a new state, this is a block state. Let's say either from new state to ready state or from block state to ready state. Some much more high priority process that is P2 has come. And assume there is CPU and currently P1 is getting executed. Okay, and this P2's priority is much more higher than P1. Okay, now operating system will see even though P1 is currently getting executed, that is fine, but P2 has much more higher priority, so we'll have to schedule P2 now. Okay, then also this scheduling thing comes up, and this P2 is getting scheduled to the CPU. Okay, so let's see the two type of scheduling. One is preemptive scheduling, another one is non-preemptive scheduling. Okay. So what happens in preemptive scheduling is, let's say there is a CPU process P1 is currently getting executed on on this CPU. Okay. Let's say P2, P3, P4, P5 is waiting on the ready state to get the CPU. Okay. So in preemptive scheduling, it may happen that even before this P1 is getting finished, your operating system may come and your operating system may pull this P1 out from CPU and may assign one of these ready processes to the CPU. So in this schedule we could see, so there is a preemption involved. So that is why this kind of schedule is called preemptive schedule. Okay. Coming to this non-preemptive scheduling, what happens is, let's say there is CPU, P1 is assigned, let's say P2, P3, P4, P5, all these states are in ready state. Okay, I mean all these processes are in ready state. Okay, so let's say P1 takes 100 second of time. So your operating system will wait for this P1 to get finished. Once this P1 is finished, then only your operating system will be picking one of these ready processes and will be giving this to CPU. So we could see here processes are not getting preempted, and that is why this kind of schedule is called non-preemptive schedule. Okay. So now we'll be seeing this throughput. Throughput is number of processes completed per unit time. Okay. Let's say in 60 second, okay, in 60 second 120 processes are finished. So 120 processes by 60 second, okay, by 60 second, then it means 2 processes per second. Okay, so if your system is completing 120 processes in 60 seconds, that means your throughput is 2 processes per second. Okay, so number of processes is 2 per unit time. All good. So now we'll see schedule. So schedule is sequence of processes that will be given to CPU. All right. So let me erase this part. Okay. Fine. Let's say there is CPU. Let's say there are multiple processes, P1, then P2, then P3, then P4, then P5. Okay. Your operating system, every time your scheduler will come and choose one of these processes from ready state and will be assigning this to CPU. So the order in which these processes are getting assigned to CPU is called schedule. Okay, let's say this at the very first P2 is scheduled, then P4 is scheduled, then P3 is scheduled, then P5 is scheduled, then P1 is scheduled. So this may be the set of processes in ready state, but this is the schedule. That means this is the order in which your CPU will come and keep on executing the processes. Okay. So let's see schedule length. Okay. So let's consider this schedule. Okay. Let's say this schedule is starting at t equal to 2 and ending at t equal to 10. Okay. So in that case, this schedule length will be 10 minus 2, that is 8. Alright, this is the schedule length. So what is schedule length mathematically? Max of, let's say this is I'll come to this thing. Let's say max of, okay, completion time, okay, across all the processes. This is across all the processes. Okay. So max of completion time minus minimum of arrival times. Alright. This is called schedule length. Okay. So there is something called scheduling algorithm. So scheduling algorithm is a rule. Okay, by this rule, your scheduler will decide which process should be given to the CPU next. Let's say we'll be taking this example. Let's say there is CPU. Process P1 is currently getting executed by the CPU. Let's say P2, P3, P4, P5. These 4 processes are waiting for the CPU. Okay, so scheduling algorithm decides among these 4 processes which process will be given to the CPU next. So there are multiple scheduling algorithms possible. Okay. So in this video, we will be seeing a very few scheduling algorithms, that too on a very high level. Okay. In future videos, each of the scheduling algorithms I will be explaining with example. So everything will be very much clear. Okay. First is first come first serve, that we all know, like a queue system. So whenever a process is coming, that is operating system keeps on putting that in a queue. so that whatever process has come early, that gets the CPU early. Okay, that is all about first come first serve. So what is SJF? SJF is shortest job first. So whenever, let's say there is a CPU, okay, and P1 is getting executed, okay, fine. Now let's say P1 is done and P2, P3, P4 is in the ready state, okay. CPU will be picking any one of these P2, P3, P4. CPU will be seeing which process has the least amount of burst time. Okay, let's say P2 is burst time as in the CPU time is 2 second, this is maybe 10 second, and this is maybe 3 second. So CPU will see, oh, P2 has the lowest CPU time. Let's schedule P2. This is all about shortest job first. Then comes round robin. So round robin says, I will be taking an example. Okay. Okay, fine. Let's say round robin says there we will be having a queue. But okay, let me take an example. Let's say there is a CPU, time quantum value is 2 seconds. Okay. So now your process 1 is getting executed at CPU. Okay. Process 1 takes 10 seconds. Process 2 is taking maybe 20 seconds. Okay. Process 3 is taking, let's say, 4 seconds. Alright. So let's say first P1 has come, then P2 has come, then P3 has come. CPU will be taking P1, will be executing this P1 for 2 seconds, alright, will be popping out from this queue, okay, and after 2 seconds, P1 will be again pushed back into the queue, saying now your CPU, now you have 8 seconds more CPU time. Then P2 is taken from this queue, P2 is also executed for 2 seconds, then how much seconds P2 is yet to execute? That is 18 seconds. So right after 2 seconds of P2, CPU will be pushing this P2 at the back of the queue. Alright, so far so good. Again, P3 will be taken, okay. So after taking P3, again P3 will be getting executed, and again after 2 seconds, the time, this time quantum expires, okay. P3 is again pushed into the queue. So we are maintaining a queue, and as well as we are respecting the time quantum value as well. Don't worry, even though round robin may not make sense as of now, but we will be seeing in detail examples of round robin. You will be understanding everything regarding the round robin. Now let's see priority scheduling. What is priority scheduling? So priority scheduling is process with the highest priority runs first. Okay. So let's say there are multiple processes, and we have already seen this example. Okay. So whenever some process with high priority comes, your CPU scheduler says, hey process, let's say P1 is running at CPU, your CPU scheduler will come and will be saying P1, hey process P1, I know, I can understand that currently you are executing at CPU level, but in the system, we have process P2 which is having much more higher priority. So please leave the CPU and let me run P2. Okay. So whatever scheduling algorithm follows this priority kind of thing, that scheduling algorithm is called priority scheduling. Okay. We'll be seeing there are many more scheduling algorithms are there, which will be, we will be seeing all of those scheduling algorithm in detail. All right. So we'll see each of the scheduling algorithm with detailed example. Everything will be super clear. So even if you could not understand few things over here, so please stay with me. Keep on watching the videos. You'll be understanding everything very deeply. All right.